Hey y'all, this is just a continuation from the last video. So, the last video we were showing you an example of area of a sector, and the example that we showed you, it had a degree. It was given with already a degree. So, we're going to go ahead and look at some other examples now. And they're going to be using degree also. So, we can go ahead and use the same formula, but I may try using the other formula just to show you how it still works. So, we're looking here, we're going to be looking at number 5. Find the area of each shaded sector. So it tells us that we have 57 degrees as our angle and 3 inches is what we're looking at here. Alright, so the formula that we're going to go ahead and be able to write is, this is for number 5, AS is equal to pi r squared theta over 360. Remember, pi r squared, this is the area of a circle. And then this degree over here of theta over 360 is the sector. This is the piece of the pie we're looking at. So when we're looking at our problem, here's my circle. Here's what we're saying, that this is 57 degrees and that this is 3 inches. Yes, 3 inches. So from here we can go ahead and just plug it in the formula. So because we're given an r, which is 3 inches, and then we're also given a theta, which a theta is 57 degrees. So we can go ahead and plug it in. So we have AS is equal to pi r squared theta over 360. So we'll go ahead and say it's pi 3 squared 57 over 360. Now this one may not give us a nice number, but we'll work with what we got. So we'll get 9 pi 57 over 360. I really don't think that simplifies to anything. Well, hopefully I'm proven wrong. Yes, I am proven wrong. Which gives us 9 pi 19 over 120. Now we can go ahead and multiply 19 times 9, which gives me 171 over 120. 5740 pi. Like I said before, I'm going to go ahead and leave it as pi. That's normally the most accurate value we can get. If we try to approximate, it won't give us the best value that we could have gotten. So let's go ahead and look at the next one. And instead of using degrees, we'll go ahead and just change it to radians. And we'll try to work with it in that manner. So the next one was number 6. And they give us 92 degrees. Yeah, 92 degrees. So we have the circle here. We're looking here. This is 92 degrees. And then this is 7 centimeters. So then when we go ahead and look at this, we can go ahead and say the area sector is equal to, now I'm going to use 1/2 r squared theta. So remember, we can't just plug in the 92 degrees. Remember, our r right now is 7 centimeters. Our theta is 92 degrees. We can't plug it in right now, so we're going to try and convert. That's going to be our first goal, is to go ahead and convert. So what we'll do in order to convert is we're going to multiply 92 degrees times 180 over pi. So using our idea of degrees canceling when they're across from one another, we get that. So we'll multiply across, so we'll get 92 over 180 pi. And we're just checking to see what we'll simplify to. 22 over 45. So that we know right now that the degree itself, actually the angle is what I want to say. 23 over 45 pi. Now we can just go ahead and multiply that by 1/2 times 7 squared. So going back to the formula, this is what we know what the angle is. So we'll say 1/2 7 squared times 23 over 45 pi. And remember, we'll leave the pi alone just as for it is. So then we know that that's 49. So we'll get 1/2 49 23 45ths over pi. Now we'll go ahead and multiply this and see what this simplifies down to. That number does not look nice, but I prefer this number over some random degree or random decimal. Voila. That turns out to be it. So that's it for this video. We just went over some examples of area sectors. So if you like these videos, go check out more of them. Thanks a lot.